Good morning. Welcome to the premium and public video discussion for Friday, March 11th, 2022. I decided to combine the two today because there's a lot of interesting information out there on social media, snow maps from model guidance and discussions of everything shifting east and whatnot. I want to thus explain what's actually happening, what's going on, and actually look at the lifting parameters rather than just throwing a snow map out there and just saying, look, the NAM is doing this, so therefore everyone should be adjusting east. So, because I've been getting a lot of comments on social media, whether it's Facebook, Twitter, what have you, of, hey, the models are all going colder. How come National Weather Service is doing this? How come I'm doing that? So rather than just say you can't just look at models, I'm going to show you what we're looking at, what I am looking at, and give you kind of an idea of why we have a forecast out the way we do. So, first of all, looking at our observations, we have temperatures in the mid to upper 30s this morning over the northern interior, lower to mid 40s along the coast. A nice little mix here. Modest Pacific air mass that's in place here with scattered cloud cover and really nice weather conditions. Now, there is our threat approaching here over the Ohio River Valley back towards the lower Mississippi River Valley. We have the subtropical jet stream starting to introduce some moisture into this whole setup, and this is associated with the polar jet stream. Here's another short wave behind that. And right now, we have high pressure and control. Generally quiet conditions. We are on the warm side of this boundary, and we're going to have a nice warm air transport and get our temperatures right up into the lower 50s over the interior and upper 50s along the coast ahead of this threat. Now, look, you can have snow accumulation after a warm day. There's no doubt about that, but it's a lot harder to pull that off the further you get into March because of the rising sun angle. It's a real pain in the neck for meteorologists when it comes to forecasting because you have to separate between what actually accumulates on the grass and what actually accumulates on the pavement. Just let's say in a perfect scenario with a well-established polar air mass or Arctic air mass in place, not trying to push in while the storm is marching its way through. So that leads me to these upper level winds. The key point here I want you to take from this is that this is a positively tilted trough. So why is that important? Well, positively tilted troughs means that your moisture and lifting parameters are all lifting off from the southwest to northeast at a pretty steady pace. Note there is no high latitude blocking back here over the Canadian Maritimes. So that means anything that forms here is just going to be trucking and marching its way through, not really going to be spending much time. It is on its way out. So, as a result, you have to take into consideration that while there is going to be a changeover, how long does the best dynamics linger over any one location? And so, with that being a case, you also have to consider how long does dynamic cooling, the rapid rising of air, influences your forecast and able to overcome other impacts like the higher sun angle in March, the warm boundary layer initially ahead of this whole event. So those are a couple of features that sometimes the models do not handle very well, especially when most of the guidance just takes QPF times 10 if the 850 millibar temperatures are below freezing. And that's pretty much the only factor in a lot of these model guidance and a lot of the snow maps that get put out there. So right now, we have clear skies and a visible satellite picture, some cloud cover with our frontal boundary off to the north and west, especially over the Poconos and Catskills, but plenty of sunshine today, allowing our temperatures to jump up and warm our boundary layer very nicely. On the infrared satellite picture, you can start to see some of the lifting associated here. We have lifting down here with our short wave in the subtropical jet stream. Here's our short wave here in the polar jet stream diving in and our frontal boundary. So you can see some modest lifting here. Nothing that's really too impressive at this time. On the water vapor satellite picture, you can make out our trough here. Nice little area lifting. Now notice, see this darker area here? This tells me the strength of the short wave. Why? because if I have rising air here, I must have a counterbalance here, sinking air. So this is a nice little shortwave here, again, in a positively tilted trough. And we do have some moisture transport, but not a lot just yet, okay? This isn't anything that is very explosive just yet. But as this low pressure system that is festering down here starts to interact with this Arctic air, that's when it starts to rapidly intensify. So basically, our intensification process, where our low pressure system rapidly strengthens, is based more on the interaction of the thermal gradient than the upper level dynamics or the support from upper level winds. Although, to be fair, when we take a look at the model guidance, and I think I'll start off with pulling up real fast the upper level winds in this scenario. Okay, and then we'll dive into some other data and walk our way through on this. So we'll use the European, as this is one of the more aggressive cold models. You could also use the NAM if you like. Again, pretty good upper level dynamics here, right? Not incredibly impressive, but strong enough. The earlier model guidance was a lot more dynamic here in this split, and what we originally had was very strong divergence and diffluence. This time, as we get closer to this threat, we have more of a scenario where you have your jet streak, for sure, setting up. There isn't as much separation between this other jet streak. We still have pretty good diffluence, but notice in this setup is that everything is moving very quickly. Very quickly. The best dynamics, the best support for a jet streak dynamics lifts off to the northeast very quickly. So again, this tells me we don't have a lot of time here for rapid intensification, and the support for the other parameters lower in the atmosphere. So this is, again, a warning sign. So definitely something to consider. Then we take a look at our 500 millibar PVA. In fact, I'll let me pull up that guidance real fast. We'll come back to you in a moment. Okay, so this is a pretty cool section where I can kind of walk through the other factors in the atmosphere. Now, here we are, 500 millibar PVA, and we'll go back to the morning, tomorrow morning, and notice again, everything from southwest to northeast, pretty progressive lifting parameter. Let me pull up here, and notice down your screen here, very fast moving and a positively tilted trough. And your time period for your best lifting dynamics are right in the middle of the afternoon, right over the northern mid-Atlantic, and then it's quickly off towards northern New England and the Gulf of Maine 6 hours later. That's very fast. You see the same thing at 700 millibars. Very strong, very fast, very brief, like 1, 2, out. Okay, again, let's walk through. In the morning, it's approaching, it hits, it's out. It's very fast. Same thing here at 850 millibars. Okay, our 850 millibar low, slow to develop this time, very quickly moving out and rapidly intensifying over the Canadian Maritimes less than 6 hours later. I mean, this thing's rocketing. And of course, there's our cold air transport. Okay, let me scroll down here. And again, ahead of this, well ahead of this, we have 850 millibar temperatures well above freezing. And of course, that means that our surface temperatures are also well above freezing in this scenario. And then as we get to noon, and about 1 p.m., again, you can see very impressive strong transport. And this would support pretty strong frontogenesis, right? So you have your cold air rapidly building in around noon, your rain's changing over to snow along the coastal plain, your temperatures are falling. By the time we get to this type of cold air at 7 p.m., most of your precipitation is gone. So absolutely, very strong cold air transport, but with that, very strong dry air transport. Why is that important? Well, let me just go back here, 700 millibars, and we'll take a look at humidity. In fact, actually, you know what? I got a better idea. Let's take a take a look at 850 millibar relative humidity. So we'll pull this up. And 850. Okay. Why is this important to me? Well, here comes our moisture swinging in Saturday morning. Notice we have all these breaks here. Okay, now this is based on the fact that we have very strong rising air and sinking air with our mesoscale banding, and also very strong dry air transport. We can also see that 700 millibars right here. Okay, here comes it comes in basically like a cold front. There's our low pressure system influence. Saturday morning, Saturday afternoon, it blasts in. By the time we get to 4 p.m., very impressive dry air transport, right? Very, very progressive precipitation shield. And by the evening, it's out. You have very dry air. This is like around 10%, right? So you have a very fast-moving shortwave. And then take a look at what's happening here from Genesis on the NAM guidance, because everyone's pulling up the NAM. They look at the NAM, the NAM, the NAM, the NAM. Okay, let's take a look at the NAM. The NAM on Saturday morning. This is our frontogenesis. Now, this would cause very strong lifting. And it books. It gets out of here fast. So from 11 a.m. to 2 p.m., it's marching its way through, in and out. So what is this all culminating to? Well, this is an evolution where you have steady snowfall over the interior. Very confident of that. The only question I really have in that scenario is the nature of the snow ratio, whether we're doing 8-to-1 to 10-to-1, or whether we get rapidly jump to 12-to-1 to push snowfall totals over 8 inches. Not as confident in that. I'm staying with the 4 to 8 inches, which I'll show you in the forecast there, because everything's moving so quickly. I think that with this strong lifting, you also have to recognize strong subsidence behind all of this lifting. So it swings through in a matter of 2 hours. You get very heavy snow bursts for about 2 hours, and then you get sinking behind it. So I'm not as confident with the snow ratio up there. Then you have the coastal plain where you have the strong dynamic cooling, absolutely, for about an hour or two, and then it's done. So you have to get all your snow accumulation to, one, overcome the warm boundary layer initially. Then you have to rapidly cool the atmosphere. Then after you have that burst, everything has to accumulate on the roadways and also on your grass. And then you have to clear out. So essentially, with that, you got roughly 2 hours to produce some of these snowfall totals of 4 to 5 inches on the coastal plain on some of the NAM guidance here, which doesn't jive with the amount of time you have and the nature of this 500 millibar pattern. So walking through here, and I'll pull up our next guidance here. And we'll walk through, we'll use the latest guidance here. And so for today, tranquil conditions, high pressures in control. Our temperatures range from the lower 50s over the interior to the upper 50s, possibly even touching 60 degrees in the Philadelphia metro today with plenty of sunshine. Tonight, clouds increase. Look for our temperatures to fall off into the lower to mid 20s over the interior, upper 20s to lower 30s along the coast. This is all ahead of the precipitation that comes in. So by the time we get to, let's say, 4 a.m., you start to see the influence of the warm air transport with our low pressure system approaching from the south. And then you can see our Arctic cold front coming in from the west. Saturday morning, our precipitation breaks out. We are above freezing along the coast. Over the interior, we start off with maybe a snow-sleet mix going over to all snow. Now, this is our frontogenesis right here. So let's watch this swing on through. So periods of rain throughout the morning hours. Here comes our Arctic cold front with our wave of low pressure steadily intensifying over the coastal waters. And this is all your best lifting and dynamics right here at 11 a.m. So you go from rain over to this moderate to heavy snow band that moves very quickly. Here we are at 11 a.m. By 2 p.m., it's already focused over Connecticut and Long Island. So again, 11 a.m., 2 hours, 11 a.m., it's over the Delaware River Valley. 2 hours later, it starts to move into Connecticut and Long Island. That's very fast and doesn't give you a lot of time. And then behind here, because you have strong lifting, you also have strong substance behind this. So yes, you have snow showers here, but they're broken up, they're very light, and this is all happening in the middle of the day in March with a much stronger sun angle. So these are all factors in which makes you pare down whatever model guidance you're looking at and say, okay, based on experience and based on the nature of the environment we're in, it's probably not a good idea to go with the max that you might be seeing on some model guidance in this scenario. And so all this clears out between 4 p.m. and 8 p.m. from west to east. And you have temperatures initially pushing up into the lower 30s over the Poconos and Catskills to the mid 40s along the coast. And then once you get that transition changeover, temperatures basically plummet the rest of the afternoon and evening. So looking at temperatures in the afternoon as we get this changeover in the 20s and 30s. By the time we get to Sunday morning, we have clear skies, tranquil conditions, and temperatures falling off into the single digits over the interior and upper teens along the coast. So anything that might be left on the roadways here that might be wet as this is coming to an end is going to freeze. So definitely put treatment down because of that. On Sunday afternoon, we have scattered cloud cover, possibly a flurry passing on through as well. Look for temperatures to rebound into the mid-20s over the interior and lower 30s along the coast. Then Monday, high pressures off the coast, and we start to moderate. Look, we have tranquil conditions, and temperatures are going to start to rebound very nicely. First, we'll have low temperatures in the lower to mid-20s, and then high temperatures with plenty of sunshine in the upper 40s to lower 50s over the interior and lower to mid-50s along the coast. Any snow you get from this scenario is going to be melting pretty quickly. By the time we get to Tuesday, high pressure will be in place with scattered cloud cover. Look for low temperatures in the mid 30s and high temperatures ranging from the mid 50s over the interior to the mid 60s along the coast. On Wednesday, look for scattered cloud cover with temperatures ranging from the upper 20s over the interior to the upper 30s along the coast. High temperatures will range from the upper 50s over the interior to the mid-60s along the coast in the Delaware River Valley. On Thursday, we have an area of low pressure passing through, all rain. Look for temperatures to range from the lower to mid-40s for lows and high temperatures in the mid-50s over the interior to the lower 60s along the coast. And on Friday, look for sky cloud cover, very mild, with low temperatures in the lower 40s over the interior and lower 50s along the coast. High temperatures in the mid-60s over the interior to the upper 60s to lower 70s, that's right, along the coast and in the Delaware River Valley. So we go from winter to spring very, very quickly. So this is what we're expecting with our impact map. Again, zone 1, 4 to 8 inches of snow likely on all your cold surfaces. We're talking about areas like Scranton, Catskills, Poconos, stuff like that. 3 to 6 inches on your roadway, so definitely plowable event up there. Zone 2 is another area where you're definitely going to need plowable conditions, where you have snowfall around 3 to 6 inches, and on the roadways 1 to 3 inches, especially if you have treatment. It's going to slow down that accumulation. Good bet to see 3-4 inches on average around here. Zone 3 is where you get that changeover where you've had rain for most of the time, and you have temperatures ranging from 1 to 3 inches on cold surfaces, trace to 2 inches on your roadways, especially if they're treated. And then Zone 4, most of this is rain, ending as snow. Look for 1 to 2 inches of snow on your cold surfaces, your grass, car tops, stuff like that, with that heavy burst. And then you basically get some lingering snow showers thereafter. Trace on the roadways is currently expected. that is your detailed forecast. I hope you guys enjoyed and understood the factors involved in this storm. We'll be keeping an eye on it throughout the day. And as always, stay safe out there.